Dear participants, I welcome all of you in this lecture of data science using Python, in which I will discuss advanced library, which is in today's lecture we'll discuss Pandas. So we'll discuss series and data frames of Pandas. We'll see how to locate elements of data frames, load files to data frames, and certain methods of Pandas that we'll discuss in today's class. So what is actually a Pandas library is? So we have seen in last lecture I discussed a NumPy array and its different attributes and certain problems related to NumPy. So that we discussed in last class. So in that you must have observed that NumPy has no way to attach labels to data. So you cannot attach column names to your data set. And NumPy has no function specific to handle for missing values. Suppose in your data set you are having certain empty value as far as certain parameters are concerned. So there could be a possibility that some record would have empty values related to some features. So there, as far as NumPy is concerned, there is no such function or method to handle missing values. Similarly, NumPy has no any function or operation to group data. Suppose you want to group your data based on certain type of data. Let's say there is a quantitative data. Let's say you have qualitative data and you want to group that data. So there is no such function and operations in NumPy. In today's lecture, we'll discuss one specific problems where I will explore how to group data and what are the purpose of grouping of data, and several problems we'll discuss related to grouping of data. And NumPy is not having any function to handle relational data as well. Suppose you are having two different data sets and there are some common attributes in these two data sets, and if you want to combine these two data sets, so there is no such functionality available in NumPy. So Pandas is built on top of NumPy to make data processing on data easier. So the thing that we discussed here, so using NumPy, that could be easily done. Using Pandas, it can be easily performed. So the thing that we discussed here, all can be performed using Pandas. So Pandas have functions and methods related to these type of activities. Storing, pre-processing, summarizing, visualizing data can all be done effectively with Pandas. So there are so much functions and methods available through which we can summarize the data. Let's say if you want to know a standard deviation of our data set related to a particular column, or let's say mean, median. So that we can also perform using NumPy. But as far as Pandas is concerned, so it handles all these very intelligently, right? And even we can visualize the data, like Seaborn and Matplotlib. So they actually need a Pandas data set to visualize the data. So using the objects of Pandas, we can easily visualize the data set using Seaborn or Matplotlib. And in Pandas, we actually work with two objects, that is series and data set. So what is series and data set? That we'll discuss. So a Pandas series is like a column in a table. So it actually a one-dimensional array. So it is having single column, right? If nothing else is specified, the values are labeled with their index number. right? So like in this case, I have in this particular example, I have not mentioned any index, right? So it automatically consider index, like in this case. So if it will mention the index as well. So 0, 1, 2. So in this way, it would assign the index value. And we can also provide index values. Like in this case, I can also provide index value. So now the data would have, let's say in this particular object, the data is, let's say it is having 33, 44 and 77. So let's say this is a list, and you are creating a series using Pandas. So what would happen? It would finally, the series would look like in this manner, X, Y, Z. So this is a single column, right? Single column, but index can be assigned to these values. So these are actually index, X, Y and Z are index. So we can create this type of series using Pandas. Now we'll discuss data frames. So data set in Pandas are usually multi-dimensional tables. So if we are using Pandas, so the data set is actually are having multi-dimensional values, right? So if you are getting any data set, suppose you are downloading a data set. So usually the data sets are multi-dimensional. So you want to work with the multi-dimensional tables, or you could say data set. So for that purpose, data frame is very very important type of object. So series is like a column, while data frame is the whole table, right? So whole table, so data set is actually a whole table. So we want to read the data set, and that data set would be read in a form of data frame object. So data frame can be treated as a collection of series, obviously, since the data frame is having multiple columns. So it is actually a collection of series. Each row has an index and each column has an index. So it means each row that we are having in the data set, let's say this is your data set. So each row would have certain index value. So you can update these index values as well. So by default it is 0, 1, 2 and so on. So these are index values that you can modify later on. So how to create data frame and how to access the data frame actually. So let's say you are having this data. This is a multi-dimensional data. Since it is having two column name, one is calories, which is having this data, so on, and duration. So that's why it is a multi-dimensional, right? And first of all, we will prepare the data. Like in this case, it is actually in the form of dictionary, and this dictionary would be passed to Pandas data frame, right? Now this variable myvar is actually now a data frame. If you would print the data frame, so somehow you will get this type of information, right? 0, 1, 2, since it is having 3 values only, 0, 1, 2. So this would be a data frame, and which data frame? That is myvar. Now to access individual rows and a particular cell value, so what we will use? We'll use data frame. This is the name of the data frame object. In this case, it is myvar, right? And this is the name of the column, right? Which is calories or duration in this case. So if you want to access the column, so we'll use df name of the column, and df is actually your data frame object. And row can be accessed using df, which is a data frame object, dot values and index values. So index values could be 0, 1, 2 and so on. So it depends on the number of records. So in this way we actually access the data. So column can be accessed using df in this way, and row can be accessed in this particular manner. If you want to access a single cell value, let's say, so what we will use? We will use df, then column name, and then values, and values could be 0, 1, let's say. So what it will access? It will fetch the cell value depending on the column name. Let's say column name is calories. So it will fetch the very first value, since I'm mentioning here 0 as an index. So in this way we can access the data frame. And how to update rows and columns of data frame? Since if we are not updating rows and columns, so by default index value would be created. Like in this case, since I have created a data frame and I am utilizing the random integer function. So what it will does, it will actually allocate 100 random numbers, right? And now I am modifying the shape, that is 10 cross 10. We have seen these functionality in last class. And now on the basis of this, I am creating a data frame object. So here data frame object is being created. Now I would rename the index, right? Since if in this case, as of now, the index will be 0 to 9. Now we can modify the index value. So I am giving it R1, R2, R3 and so on, R10. So these would be the new index, and the column names would be C1, C2, C3 and so on. So in this way we can modify the index and columns as well. The other way, since it is having a long column names, right? Since it is having 10 columns and 10 index. So if you want to write a single statement to mention column names and index names, so we can apply for loop here inside this index, like in this case. So what it will do? It will give you, since for j in range 1 to 11. So what it will give? It will give you R1, then R2 and so on, R1 to R10, 1 to 10. Similarly, the column value would be C1 to C10. Right? In this way, I can, let me erase this one. So instead of mentioning individual column names and index name, I can utilize the for loop to create a list of index and list of columns, right? So in this way I can mention. Now how to locate a row? We have seen how to locate individual columns and individual rows as well as individual cell values, right? We have seen it using, let's say df is the data frame object. So if I am mentioning column name, so in this way I can access individual column. If I am mentioning df dot values and then index number, right? So let's say 1. So it would give me the single row, right? The second row in this case. So in this way we can access it. The other way is you can use lock attribute as well as iLock attribute to access the rows and columns. So Panda use the lock attribute to return one or more specified rows. So and similarly Pandas also uses iLock attribute to return one or more specified rows. So what is the difference between lock and iLock? So lock is actually explicit index attribute mentioned by the user, and this one is the implicit mode of access. It means whether you are renaming or index or not, you can always use iLock, implicit location, like in this way. So if suppose if you have renamed your column name, index name, like in this case, we have renamed it, right? So you cannot use lock attribute in that case, right? Like lock 0, 1, you cannot use, since location at the index have been updated. But iLog can always be used in this manner, right? Whether you have updated your index name or not, so you can always use iLog. So that is the difference between location and iLog. So, and iLog in this case, it returns element present at first row and second column. Similarly, you can use values separated with comma to access a specified cell or more than one cell. It depends how you are passing these index. If you are using slicing operator, then you can access more than one columns as well as more than one rows, right? So in this way, we can access the data. Very soon, I would switch to editor, and there I will discuss all these options. So like in this case that I was telling, that we can access the more than one columns or more than one rows, so using the slicing operator. Like in this case, what it is doing, this is for we can access more than one row and more than one column. Like in this case, you are trying to access the row number 0 and 1, and here column number 1 and 2, right? Here in this case, I am trying to access all the rows and column number 1 and 2, right? So in this way, we can access the data. And how to load files into a data frame? So Pandas can read file and load it directly into a data frame. Let's say you are having a data set, and you can read your data set, and let's say this data set is somewhere in your Google Drive, or your data set is in your own local machine. Then you can read that data set, and there is a specific method that will actually store this data set into this data frame object. Now you can utilize this data frame object to perform your different type of operations. So these are the certain methods of Pandas that are very much useful, like toString to print the entire data frame. If you want to print entire data frame, so in this case, it would print, suppose you are having thousands of records in your data set. So it would print thousands of records, and information is to give more information about the data set. So what are the attributes and how the number of attributes, total count of the attributes, data type of attributes. So all these can be known using this function info. Describe, actually the method gives us the descriptive statistical information about the data sets. What is mean, median, and then 25 percentile, 75 percentile, and so on. So it gives you several type of information. So we discussed there are like toString, info, describe. There are certain more methods are there which are head, tail, and iter. So head actually gives you the number of it actually returns the headers and a specified number of rows from top. So if you are not giving any argument in this case, so it would return top 5 rows. If I am giving 10 here, so it will return top 10 rows. And as far as tail is concerned, so it returns the rows from the bottom. So if you are not giving the parameter, then only 5 rows from the bottom would be returned. Iter row is very important. If you want to access individual rows of the data frame, so you can utilize this method to iterate individual rows using the index and series. So index series, so we can utilize these like I can use for I comma j in, let's say my data frame object is df dot iter rows, right? So this is actually your index, and this one is the the number of columns, right? So if suppose in your data set you are having 10 columns, so individual columns I can access using j, and let's say the very first column name is c1, so I can access the very first column in this case. So this we can use to read individual rows and columns. So pandas are having several statistical methods that we can directly utilize, very similar to NumPy. So we can find out the count of this particular column. Let's say there is a column distance. If you need to find out the total number of cells in this particular column, so we can find out using count. Similarly, if you need to find out the mean of that particular columns, single column, median and quantile, so all these we can use using these statistical methods. So before summarizing, let me switch to the editor. There I will discuss some how to create data frame and how we can display the individual rows and columns. So here I am accessing Google Colab. So first I have uploaded a data set here, crop recommendation, and you can create a data frame here, like in this case. Let's say I'm creating a data frame as, first of all I need to import pandas as PD. Let me increase the size here. So yeah, import pandas as PD, and I can create a I can access df is equal to PD dot read underscore CSV, and here I will read crop recommendation, right? So print df. I'm trying to execute this one. So sorry, crop recommendation dot CSV. So yes, so I have uploaded one data set here. You can upload the data set. I have already discussed how to use Google Colab. So you can upload the data set using this particular option. Yes, okay. So I can, let me load one more data set here. Like I have one more data set of predicting gold price. Now I can read these data set here. So I'm reading this data set in this case. Now, if I need to find out the information of this data set, so what I will use, I will utilize info. So, right. So it would provide information of this one. So you can see here that these are certain features, and the total number of records present of these features are 2200, and all are not non-null, right? And these are data type of this data set. So in this way I can get the information. Now let me utilize one more cell, and here I will print df dot describe, right? So I can use this particular function to describe this data set. Now you can see here, as far as individual features are concerned, so count of these individual features, so it is actually coming in the form of float. So we have seen the total number of records are 2200. So that's why count is coming as 2200 in each and every features, right? So these are features. Nitrogen, value of nitrogen, phosphorus, and then temperature, humidity, and then pH value, rainfall. So all these are actually features of this data set, that is crop recommendation, that we have already discussed when I was explaining different type of data sets. Now we can find out mean, standard deviation of each individual features. Minimum value 25 percentile, 25% percentile, 50 percentile, that is your mean. Mean has already been given here. Median values, so this one is the median value, and then maximum. So all these can be you get to know all these using info. Now I can use how to access individual column names. So I have already told you, here I can utilize temperature, right? So I can print individual column in this manner, right? So these are the values of a temperature column, temperature feature. Now I want to display single cell. Let's say temperature, then I log, and to 0, right? And here I am printing. Let me write this one here, and right. So let me print this one. All right, print. Yeah, let me execute this. Sorry, there is error. df. I'm trying to run this one. So these are certain values. Now let me print individual cell. So this one is the the very first cell value of the temperature column. So this value, this particular value. In this way, I can access the data members. Now I can use slicing operator to display some more values. Let's say 0 to 10. So it would display these values, 10 values, right? So in this way, I can explore individual data members, and I can also display the data using df ilog, and then 1 or 2, and here let's say 4. So you can see here, so the values are P42, 58. So it means it is giving me 4 rows starting from 0, 1, 2, 3, and this one is the column. So 1 and only 1, right? So 1 is here, which is P, right? So this one is the 0th column, and this one is the first column, right? So in this way, I can explore certain more data. Now let me use log, right? So why I'm not able to, let me use 0, right? df.log. So you can see here the value at 0th index, right? So 0th index, it means this whole value. Why am I able to get the value using log? Because the default index values are 0, 1, and so on. So in this data set, I have not renamed the index value. I can rename it here, using index is equal to, but it is having 2200 individual rows. So I'm not going to rename it. I can utilize these index values here. So in this way, I can access the individual data members and different columns and different rows and so on. I hope it is clear to you. Let me see if something is missing here. So I have used these to string, and then ilog. I have already discussed ilog, and then I discussed how to rename the column. Yes, I can rename it. I can rename it the index using a for loop, right? Like in this case. Here I can rename the data set using df dot index is equal to, and then let's say index row, I'm going to rename it, then plus j and string j, str j, and j in range 1 to 101, right? So j in range 1 to 101, right? So not 101, in this case it is 22 2200 rows are there. So 2201. Let me execute this one. So for j in range, right? So for was actually missing here. Now it has been renamed. Column row name has been renamed here. So in this way, I can utilize different attributes of pandas. Let me switch to the PPT now. So we have seen, now I'm summarizing what we have discussed till now. So we have seen the basics of pandas and how actually it is different from NumPy, and why there is a need of using pandas, right? So it actually gives you several type of methods and functionality for data pre-processing, data visualization, and so on. Series and data frames of pandas. So we discussed the difference between series and data frames. So series is individual column, and data frame is collection of series, actually you can say. So we have seen locate elements of data frames and how to load files to data frames using read_csv method, and we have seen certain methods of pandas and certain methods like info, describe, and so on. So we discuss all these concepts in today's lecture. Thank you so much. We'll meet again in next lecture.